For this example, I want to solve the following simultaneous equations for x and y. We have 2x plus 3y, which is equal to 8. I'll call that equation number 1. And we also have 3x minus 6y is equal to minus 9. And I'll call that equation number 2. To solve this pair of equations, I'm going to attempt to get either the coefficient of x to be the same or the coefficient of y to be the same. This is the elimination process. So you notice I have a 3y in equation number 1, and if we just ignore the sign for now, we have a 6y in equation 2. So you should notice that if I multiply equation 1 by 2, I will get a 6y, which is, ignoring the minus sign still, the same as what I've got in equation 2. So let's do that process. Let's take equation 1 and multiply through by 2. So I have 2x times 2, which gives me 4x. I have 2 times 3y, which gives me my 6y. And I have 2 times 8, which is 16. This I will now call equation number 3. And I will write below it equation number 2. 3x minus 6y is equal to minus 9. Now, as I said, ignoring the signs, we've now got the same coefficient for y. And now we either need to add the equations together or subtract the equations to eliminate, in this case, the unknown y, leaving us with just an equation in terms of x. When we have different signs on our coefficient, as we've got here, we've got a plus 6y and a minus 6y, we add our two equations together. So we're going to do equation 3 plus equation 2. If the signs in front of our coefficients were the same, either plus and a minus, then we would have subtracted the two equations. But as the signs are different, we add them. So what do we now find? We have 4x plus 3x gives me 7x. 6y plus minus 6y cancels out to leave me with 0y. And I have 16 plus minus 9, which gives me 7. So I now have an equation with a single unknown, 7x, which is equal to 7. And by dividing both sides by 7, remember what we do to one side, we do to the other, I see that x is equal to 1. To now find y, I need to substitute x is 1 back into either equation 1 or equation 2. It doesn't matter which one you substitute into. Let's substitute into equation number 1. So equation number 1 says I have 2x plus 3y is equal to 8. Now I know x is equal to 1. So I have 2 lots of 1 plus 3y is equal to 8. 2 lots of 1 is 2. So I have 2 plus 3y is 8. And now I want to get this 3y on its own, so I'm going to subtract 2 from both sides to leave me with 3y is equal to 6. And dividing both sides by 3, I find that y is equal to 2. So I've got my solution, x is 1 and y is equal to 2. Now it's always a good idea to substitute your two values back into the equation that you haven't used, so substitute it back into equation 2 and check that the values work. So we know 3x minus 6y should give me minus 9. So I have 3 lots of 1 minus 6 lots of 2, my values of x and y. 3 lots of 1 is 3, minus 6 lots of 2, which is 12, so we have 3 minus 12, which is minus 9, which is exactly what we were looking for. So we can be confident now that we've got the correct answer. The solution to these two equations is x is 1 and y is 2, sometimes written as a coordinate 1,